Hello dear learners, welcome to Engineering Chemistry lecture, unit number 2, Fuels and Combustion. Let us start the lecture number 2. What you are going to learn in today's lecture? First, determination of calorific value of solid fuel by using bomb calorimeter, its construction and working, observation and calculation, and lastly the correction formula for bomb calorimeter. Determination of a calorific value of solid and liquid fuel is carried out by using bomb calorimeter. What is the principle? Total heat produced by the combustion of a fuel is absorbed by known weight of water, and from the rise in temperature of water calorific value can be calculated. So whatever the combustion of the known amount of fuel takes place, it is whatever heat is liberated out, it is absorbed in a known weight of water. So that heat in terms of temperature is calculated, and so hence we can easily calculate the calorific value of that given fuel. Construction and working. This is the diagrammatic bomb calorimeter. Look at here. This is a copper calorimeter surrounding which air jacket and water jacket is revolved, airtight jacket in which a water is filled. Inside this copper calorimeter, a bomb pot, stainless steel bomb pot is attached. Surrounding this bomb pot, there is a water field in which one thermometer and one electrically operated stirrer is attached to revolve the water and thermometer to know the temperature of that water. In this stainless steel packed bomb pot, one empty crucible is taken in which that coal sample like solid fuel is taken. That coal sample is attached to the magnesium fused wire. Those wires are attached to electrodes, and those electrodes are attached to the 6-volt battery to create the electric spark. So a very simple mechanism. Just what we have to do at the beginning, we have to start the charge through these two electrodes. Charge is transferred to the magnesium fused wire. These two wires get fused and give the spark to this known amount of the fuel sample. Now when the fuel sample in presence of this oxygen through this oxygen wall is start the combustion, heat is liberated. As we already know, fuel plus oxygen, it gives the combustion product plus the heat. So whatever heat will be increased before that, before this we have to know the initial temperature by using this Beckmann's thermometer, and when a complete combustion of this fuel takes place, the temperature surrounding a water of this bomb pot get increased, and increasing temperature is nothing but the amount of heat liberated by this known amount of the fuel sample. Now what are the observation and calculation? Look at here. X is nothing but the mass of fuel sample taken in a crucible. W is nothing but, capital W is the mass of water in copper calorimeter. So how much water we have taken, that is known as a capital W. Small w is the water equivalent in grams of calorimeter, stirrer, thermometer and bomb, etc. T1 is the initial temperature of the water that measure before combustion of fuel takes place, and T2 is the final temperature of water. So the most temperature increases is known as a T2, and rise in temperature is calculated by using T2 minus T1. L here is in terms of higher or gross calorific value. Calculations. L into X is equal to W T2 minus T1 plus small w T2 minus T1. So in short, L, that is a GCV, is equal to, this is the formula, in bracket W plus W, bracket complete, again bracket T2 minus T1, bracket complete, upon X, where X is the known amount of fuel that we burnt. How to calculate the net calorific value? It is calculated by using this formula. Once you know the L, that is gross calorific value, we can easily calculate the NCV. So NCV is equal to GCV minus 0.09 into percentage of hydrogen into latent heat of the water vapor form. So this is the short form, that is NCV is equal to GCV minus 0.09 into H into 587 into 4.187 kilojoules per kilogram. Now there are some corrections in the calculation. What we have to subtract first, TA, that is acid correction. Now may it happens that fuel contains some sulfur or nitrogen in trace amount, which is converted into sulfuric acid or nitric acid. Those also form some heat that should not be the heat of that particular fuel combustion. So we have to subtract it from the total GCV value. Second is cotton thread correction. Whatever the cotton we are using, that thread we are using, that also burn inside the bomb, and that also produces the heat, which is not the heat produced by that particular mass of the fuel. So that also we have to subtract. And third, the fused wire correction. We know that to give the spark to the fuel sample, we need a magnesium fused wire. Those wire after burning also produces the heat that we have to subtract from the total gross calorific value. These three things we have to subtract. Then what to add, what is remain in that gross calorific value? We have to add the cooling correction. And after converting all these, the three important aspects we have to subtract and one we have to add, we are getting L, that is GCV, is equal to W plus W, T2 minus T1 plus TC. Now look at here, TC, that is cooling temperature, we have to add into bracket complete, minus, here minus, that we have to TA plus TF, we have to subtract upon X. What you are learned from the lecture: bomb calorimeter, construction and working, calculation, correction formula. Thank you.